Welcome. Have you seen the headlines? Part of the sun broke off and scientists are baffled. Well, this is just another example of hype on the internet, and I'm going to show you that this is something that's fairly common and any decent scientist is not in the remotest bit baffled. All this hype just seems to be more clickbait. When I did a search on the internet, I found 22 million articles claiming that part of the sun had just been expelled. Unfortunately, some of the major news outlets got involved in this, like CBS, NBC, ABC, and even PBS. Of course, the Daily Mail got involved, but that's to be expected. And of course, there was hundreds, if not tens of thousands, of articles on the internet, some by people who should know better, claiming that this was something amazing. Some of the articles claimed that it had been sucked into a polar vortex. Now, I know what a polar vortex is on Earth, but I don't know what it is on the sun, and I'm sure that they don't either. Of course, if this part of the sun that had broken off had been sucked into a polar vortex, it actually hadn't left the sun. So this is sort of a contradiction from what they were originally claiming. Most claim that this was something extraordinary, and I'm going to show you that this is actually something quite commonplace. In fact, it happens nearly every day on the sun. It claimed that scientists are baffled about what's happening to our sun. Now, anybody who's a halfway decent scientist that knows anything about the sun is not going to be the remotest bit baffled by this. This, as I say, is a common phenomenon. And so those claiming that the scientists are baffled are not really paying attention or just trying to fool you. The first thing I'd like to point out is mass escapes from the sun continuously. The solar wind has a velocity of about 200 to 800 kilometers per second. The escape velocity from the sun is about 615 kilometers per second, which leads to a mass loss of about 2 million tons per second on the sun. Now, don't worry, the sun has lots of mass and won't even notice this loss rate. Coronal mass ejections, which are eruptions of filaments and from flares, about 5 of these happen a day. And this is actually an example of a filament eruption, or what we're going to be talking about, but a very special example of a filament eruption. There's 20,000 of them during a solar cycle. The velocity of those is everything from 100 to 2,000 kilometers per second. So a large number of them are well in excess of the escape velocity. The average mass loss from this is about 1 million tons per second. Now, the thing that we're going to show you is actually a very, very small mass. It's an absolute minuscule amount of mass compared with these sorts of numbers. So it's not even very important. If you want to see an example of mass loss, look at some of the videos I've done on the coronal mass ejections. If you look at the coronagraph, particularly the SOHO, LASCO C2 and C3 coronagraph, you see coronal mass ejections all the time, and they look rather like this. The one on the left in red is the high resolution inner field of view, and you can see vast quantities of mass blowing off of near the North Pole in this particular image. And here is the large field of view version of that exact same event, but it's stretching out to several solar radii from the sun. And so this is actually an object that is larger than the sun. These are some of the largest objects in the solar system. If this is just a form of a filament or prominence eruption, what is so special about it? The only special thing about it is where it's occurring, and that's near the polar regions of the sun. Something called a polar crown filament forms near the poles, and I'll explain why that happens in a minute. But you can see here at the east and the west ends there are prominences sitting up above the limb, and in the middle, just above the limb but on the far side, you can see a faint structure. That's a filament. And on the disk you can see is a dark structure stretching from one of those prominences to the other. A filament and a prominence are the same thing. A filament is a prominence seen on the disk. A prominence is a filament seen on the limb. The prominence appears bright because it's contrasted against the dark night sky. The filament appears dark because it's contrasted against the bright sun. And so we have this filament formed all the way around the sun. It's called a polar crown filament. And every now and then, one of them erupts. And that's what we're seeing here. So this is nothing special at all. It happens all the time. And so I don't know what people are making a fuss about it and making up new terms to impress people or to get more clicks. So what is actually happening here? We'll take a diagram of the sun looking down on the top. The circles here are lines of latitude, and the numbers going from 0 to 360 are lines of longitude. At some part of the cycle, one whole hemisphere has a distinct polarity, which is negative in this case in the north. The polar region has the opposite polarity, which means a neutral line forms between the two, and that's where filaments and prominences can form. As time goes by, a flow on the sun called the meridional flow carries the negative flux towards the pole and starts to cancel that positive flux. And when that happens, the filaments and prominences become unstable and can erupt. This happens all the time. Well, as that happens, the polar region becomes more and more eroded and smaller. Eventually, enough negative magnetic flux will be exported to the polar regions to cancel it entirely. That occurs with something like solar maximum within a few months of solar maximum. And then the cycle starts all over again. You build up a strong negative flux at the polar region, and when the next cycle starts, you'll have predominantly positive in the northern hemisphere, and that will start eroding the negative polar region. I'm now going to show you a series of videos from the first 4 months of 2023 of the northern polar region and the polar crown filament there. I want you to see how many times you can see that polar crown filament try to erupt. Begin to do it again here. And again. Here's the event that they were talking about. And again. Here it goes again. There it went. Still trying to do some more. There it goes. Yep. Bits of it are erupting all the time. It's rising again. Here the filament itself gets very big and dark. It crosses all the way across the face of the region. So what conclusions can we draw from all of this? Such polar crown filament eruptions are not unusual. They occur many times during the solar cycle at both the north and the south poles. They are a natural part of the solar cycle. The polar regions are eventually neutralized at about solar maximum. So this is one way of telling you when you're near solar maximum, and we aren't there yet. So that's it for today. Thank you for watching. Stay safe until next time. Goodbye.